So in this video, we're going to go over the problems that are in the Unit 2 test review. So in this first problem, it says which domain restrictions apply to this rational function. So remember, to figure out the domain restrictions, what we need to do is we need to set the denominator equal to 0 and solve for x. Because remember, the function will not have a domain value at any values that make the denominator 0. So we have x squared minus 16 as our denominator, and we're going to set it equal to 0. Well, x squared minus 16, if you remember, that's x squared minus 4 squared. So we can factor that as the difference of two squares, x plus 4 times x minus 4 equals 0. So if we set each factor equal to 0 and solve for x, we now get these two values. We get x equals negative 4, and we get x equals 4. So we would say that x does not equal negative 4, and x does not equal 4 in the domain of this rational function. So now let's try solving this problem for x. So notice we have a rational equation here, and so what we need to do is we need to follow these steps. We're going to start off by factoring all the denominators in the equation. So x minus 5 doesn't need to be factored, but we can factor the x squared minus 25, right? So that is once again the difference of two squares. We have x squared minus 5 squared. So that will be x plus 5 times x minus 5. And the x plus 5 can't be factored. So we're just going to write this as 3 over x minus 5 minus 2 over x plus 5 times x minus 5. And that equals 5 over x plus 5. So now we need to find the LCD of all the fractions in the equation. So the LCD is going to be the least common denominator, so we're going to pick up a factor from each fraction and then not repeat any. So from the first fraction, we have x minus 5. And then we go here to the second fraction, we have an x plus 5. We have another x minus 5, so we don't need to write it twice. And then we have another x plus 5, so we don't need to write that twice. So we're going to multiply every single fraction in this equation by that x minus 5 times x plus 5. So I have x minus 5 times x plus 5 times 3 over x minus 5 minus 2 over x plus 5 times x minus 5 times x plus 5 times x minus 5. And that equals x minus 5 times x plus 5 times 5 over x plus 5. So now let's cancel any common factors we have. So here the x minus 5 and x minus 5 cancel. Here x plus 5 and x plus 5 and x minus 5 and x minus 5 cancel. And then here x plus 5 and x plus 5 cancel. So we have 3 times x plus 5 minus 2 equals 5 times x minus 5. So let's go ahead and continue solving this problem. So we have 3 times x plus 5 minus 2 equals 5 times x minus 5. So to solve this equation, we're going to need to use the distributive property. So we're going to distribute 3, and we're going to distribute the 5. So we get 3x plus 15 minus 2 equals 5x minus 25. So now let's go ahead and combine these two like terms. We have a 15 and a minus 2, so we have 3x plus 13 equals 5x minus 25. And now let's combine the 5x and the 3x. So we're going to subtract 5x from both sides. And when we do that, we get negative 2x plus 13 equals negative 25. And now we're going to subtract 13 from both sides. And when we do that, we get negative 2x equals negative 38. We divide both sides by negative 2, which gives us x equals positive 19. So you want to always go back and check by plugging into your equation to make sure that we don't have any extraneous solutions. So that gives us 3 over 19 minus 5 minus 2 over 19 squared minus 25. And that equals 5 over 19 plus 5. All right, so we're plugging back into the original equation. So that gives us 3 over 14 minus 2 over 19 squared. And 19 squared is 361. So we have 361 minus 25. And that equals 5 over 19 plus 5, which is 24. So we have 3 over 14 minus 2 over 361 minus 25 is 336. and that equals 5 over 24. And you can do this on your calculator, 3 over 14 minus 2 over 336. And when you do that, you get that 5 over 24 does equal 5 over 24. So this solution is valid and it does check out. So x equals 19 is the solution to our problem. So now let's go ahead and add these two rational expressions together. So when we're adding, remember, we're always going to be on the lookout for a common denominator. So in this case, we do have a common denominator, right? Both denominators are exactly the same. So we can just go ahead and add the numerators together. So we have 4x plus 1 plus negative 2x plus 5. And we're just going to put that all over the same denominator, right? The like denominator. So now let's go ahead and combine like terms in the numerator. So we have 4x minus 2x plus 1 plus 5 over x squared plus 3x. And so when we combine these, we get 4x minus 2x, which is 2x, plus 1 plus 5, which is 6, and that's over x squared plus 3x. So remember, you always want to factor the numerator and denominator at this step to make sure that it can't be simplified further. So if I look at 2x plus 6, notice that these two terms have a GCF, right? The GCF is 2, so if I go ahead and divide that out, I get 2 times 2x over 2 plus 6 over 2. So that gives me 2 times, and I have x plus 3. And then my next thing I need to factor is that x squared plus 3x. So if I look at that, I have a GCF of x. So if I factor out the x, I have x squared over x plus 3x over x. And so that leaves me with x times x squared over x is just x, plus here the x and x cancel, so we have x plus 3. So when I rewrite this answer that I got in factored form, I have 2 times x plus 3 over x times x plus 3. So we can cancel this common factor that we have, this x plus 3, so our final answer is just going to be 2 over x. So make sure that you always check and make sure that you can simplify your answer. So now let's go ahead and add 5x plus 1 over x plus 6 over 2x squared minus 6x. So here we have unlike denominators, right? So we need to figure out how we can make a like denominator. So what we need to do is we need to factor the denominator of both expressions to see what we have. So we can't factor x, but we can factor 2x squared minus 6x. Notice that it has a GCF. The GCF will be 2x. So if I factor that out, that's going to be 2x times 2x squared over 2x minus 6x over 2x. So when you factor that out, we have 2x times 2 and 2 cancel, and then x squared over x is just x, minus 6 over 2 is 3, and then x and x cancel. So let's go ahead and write these two fractions now with the denominator factored. So we have 5x plus 1 over x plus 6 over 2x times x minus 3. So now let's figure out the least common denominator, right? The least common denominator, we're going to take a factor from each denominator and not repeat any. So for the first one, I have x. And then I have a 2. I don't need to repeat this x. And then I have x minus 3. So that's going to be the common denominator. So to get that, I need to take that first expression and multiply by 2x minus 3, right? Those are my missing factors. So I'm going to multiply that by the numerator and the denominator, right? Because I can only multiply by 1. And then if I look at the second fraction, notice it already has the common denominator. So I don't actually need to change that fraction. I'm just going to leave it just as it is. So here what I'm going to do is I'm going to start off by multiplying that x minus 3 and that 5x plus 1. So when I do that, I'm going to use FOIL. So I do first times first. So I get 5x squared. Outside, so x times 1, so plus x, and then inside, minus 3 times 5x, so minus 15x, and then last times last, so negative 3 times 1, so minus 3. So I have 5x squared, 1x minus 15x, so minus 14x, and then minus 3. Well, remember, I also have that factor of 2 in front, so I'm going to multiply that by 2. So that's going to give me 10x squared minus 28x minus 6. So now let's go ahead and rewrite this problem now using the common denominator we just found. So we have 10x squared minus 28x minus 6 over 2x times x minus 3 plus 6 over 2x times x minus 3. So now let's go ahead and add these two numerators together. So we have 10x squared minus 28x minus 6 plus 6 over 2x times x minus 3. So the minus 6 and plus 6, those two are going to make 0, so they're going to cancel each other out. So we have 10x squared minus 28x over 2x times x minus 3. So what we need to do now is we need to factor that numerator to make sure that it can't be simplified any further. So we have 10x squared minus 28x. So we have a GCF, right? We can factor out a 2 and we can factor out an x. So we have 2x times 10x squared over 2x minus 28x over 2x. And then we have 2x times 10 over 2 is 5, and then x squared over x is just x, minus 28 divided by 2 is 14, and then x and x cancel. So let's go ahead and rewrite our answer now in factored form. So we have 2x times 5x minus 14 over our common denominator, which was 2x times x minus 3. So notice that we have this common factor now of 2x and 2x, which can cancel out. So we are left with 5x minus 14 over x minus 3. And that is now our final answer. So now let's go ahead and simplify this expression here. So what this is, although it looks like one giant fraction, it's actually just a division problem. Okay, so notice that like I have 2x squared over x plus 5. Okay, so that's going to be my first fraction, 2x squared over x plus 5. And then this fraction bar here tells me that I'm dividing the second fraction, which is 4x squared over x minus 1. Okay, so this is really just a division problem. It just looks like one giant fraction. So you can rewrite it using the division symbol just so you know what is going on in this problem. So remember, when we divide rational expressions, what we're going to do is we're going to keep the first fraction and then change it to a multiplication and then flip the second fraction, right? X minus 1 over 4x squared. So now what we need to do is we need to factor the numerator and denominator of both fractions so we can cancel any common factors. Well, if we look at this, we can factor that first numerator as 2 times x, right? And that's over x plus 5. And then we have times, we have x minus 1 over 4x squared, which is 2 times x times x. Okay, so now let's look for common factors. So we have a 2 and a 2 that will cancel. We also have an x, and then another x and an x. So what we're left with in the numerator is just going to be x minus 1. And then in the denominator, we have 2, right? We have 1, 2 left. So we have 2 times x plus 5. And that is our final answer that we get when we multiply everything together. Now let's simplify this expression. So once again, this is just a division problem that's written as one giant fraction. So we have 6x squared minus 15x over x squared minus x minus 12 divided by 12x squared minus 30x over 5x squared plus 14x minus 3. Okay, so I'm going to use my same strategy. I'm going to keep the first fraction, 6x squared minus 15x over x squared minus x minus 12. I'm going to change it to a multiplication, and then I'm going to flip the second fraction. Okay, so now we're going to factor all of these numerators and denominators. So if I look at 6x squared minus 15x, I have a GCF. I can factor out a 3, and I can also factor out an x. So if I factor that out, I have 3x times 6x squared over 3x minus 15x over 3x. So that is going to leave me with 3x times 6 over 3, which is 2, and then x squared over x, which is x. Then I have 15 over 3, which is 5, and then x and x cancel. So now let's go on to the denominator. So we have x squared minus x minus 12. So I need two factors of negative 12 that are going to add up to negative 1. Since 12 is negative, I'm going to have a positive and a negative factor. Since 1 is negative, I'm going to make the bigger factor negative. So the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So notice that 3 and negative 4 does give me negative 1, which that means that is the combination that I need. Okay, now let's do 5x squared plus 14x minus 3. So this is one of those where a does not equal 1. So I'm going to multiply a times c together. So that's going to give me 5 times negative 3, which is negative 15. Now I need two factors of negative 15 that are going to add up to positive 14. Since 15 is negative, I need a positive and a negative factor. Since 14 is positive, I'm going to make the bigger factor positive. So I have 1 and 15. And I have 3 and 5. So the correct combination that's going to give me 14 is negative 1 and 15. So this one I'm going to need to factor by grouping. So I have 5x squared minus 1x plus 15x minus 3. So if I factor these out, I'm going to put them into two groups. So 5x squared minus 1x plus 15x minus 3. So from the first set, I can factor out an x. So that's going to leave me with 5x squared over x minus 1x over x. And then from the second group, I can factor out a 3. So that's going to give me 15x over 3 minus 3 over 3. So when I do that, I get x times 5, and then x squared over x is just going to be x. And then minus x and x cancel, so we have minus 1. In the second set, we have 3 times 15 over 3 is 5, and then we have x, and then 3 and 3 cancel, so we have 5x minus 1. So now when we write out those factors, that is going to, factor out that common factor of 5x minus 1, and then what we're left with is x plus 3. So now all we have left to do is factor the second denominator right here, that 12x squared minus 30x. So let's go ahead and factor that. Notice that these two terms have a GCF, so I can factor a 6 out of both terms and an x. So if I factor out 6x, I have 12x squared over 6x minus 30x over 6x. So when I factor these out, I have 6x times 12 over 6, which is 2, and x squared over x, which is x. And then minus 30 over 6, which is 5, and then x and x cancel each other out. So now let's go ahead back to the original problem, right? So our 6x squared minus 15x over x squared minus x minus 12 times 5x squared plus 14x minus 3 over 12x squared minus 30x. Okay, I'm just reminding you of what we were doing because I'm going to replace all of these with the factored form. So 6x squared minus 15x, I'm going to write that as 3x times 2x minus 5. Okay, so that's what we found when we factored. So 3x times 2x minus 5. X squared minus x minus 12, remember we said was x plus 3 times x minus 4. And then times, we have 5x squared plus 14x minus 3, which we factored into 5x minus 1 times x plus 3. And then finally, we factored 12x squared minus 30x as 6x times 2x minus 5. Okay, so now we're going to look at all of our factors and see if there's any common factors that we can go ahead and cancel out. So we have a 2x minus 5 and a 2x minus 5. Then we have an x plus 3 and we have an x plus 3. So to see what cancels here, this 6x, I'm just going to rewrite that as 2 times 3x. Okay, so when we do that, you can see that this 3x and 3x will cancel. Okay, so all we have left now in the numerator is this 5x minus 1. And then in the denominator, we have this x minus 4. And then we have this 2 left. So that's going to be 2 times x minus 4. And so this is the final simplified form of this answer of this actually, it was originally a division problem, right? It was a division we turned into a multiplication. So now let's go ahead and multiply these two rational expressions together. So we have 3 times x plus 2 over x times x minus 4, and that's times 6x over 15, and then we have x plus 1 and x plus 2. So let's see if we can factor anything. The only thing I can see that's not factored is that 6x. So I'm just going to go ahead and rewrite this with that 6x being factored. So we have 2 times 3x times x plus 1 over, and then, oh, actually, we can also factor that 15, right? We can write that as 3 times 5, and then we have x plus 2. So remember, we can factor anything as long as one is in the numerator and the other is in the denominator. So this x plus 2 and this x plus 2 will cancel. This 3 will cancel with the 3 that's in that denominator, okay? So it won't cancel with this 3 that's in the numerator, but it'll cancel the 3 in the denominator. And then we have this x and x that will cancel. And I don't see any other factors that will cancel out. So let's see what we have left. So in the numerator, we have 2 times 3. And then we have an x plus 1. And then in the denominator, we have this 5. And then we have our x minus 4. So if we write this out, we just have 6 times x plus 1 over 5 times x minus 4. And that is our final answer. So now let's go ahead and subtract these two expressions. So whenever we're adding or subtracting, remember you want to have like denominators. So in this case, we do have two like denominators. So let's go ahead and subtract the numerators. We have x squared plus 6x plus 8 minus x squared plus 3x minus 7. Right? Remember, all of that second expression is being subtracted. So we need to distribute that negative, okay? You can pretend it's like a -1 and then go ahead and just switch all of the signs on that second polynomial to the opposite. So we have x squared plus 6x plus 8 and then plus, and then all of these are going to be opposite. So we have negative x squared minus 3x, and then that minus is going to become a positive. So that is over x squared plus 7x plus 10. So when we write this out, we have x squared plus 6x plus 8 minus x squared minus 3x plus 7 over x squared plus 7x plus 10. So now let's rewrite the numerator by combining all the like terms. So we have x squared minus x squared. We have plus 6x minus 3x. And then we have plus 8 plus 7. So that is over x squared plus 7x plus 10. X squared and minus x squared cancel. 6x and minus 3x, that's 3x. Plus 8 plus 7 is 15. And that is over x squared plus 7x plus 10. Now we need to factor the numerator and denominator and see if there's any common factors we can simplify. So if we look at 3x plus 15, notice it has a GCF of 3. So we can factor that out. We have 3 times 3x over 3 plus 15 over 3. So that equals 3 times 3 and 3 cancel, and we have x plus 15 over 3, which is 5. So now let's factor the x squared plus 7x plus 10. So the 10 is what we need to factor. We need two factors of 10 that add up to 7. So since 10 is positive, the factors are going to have the same sign. And since 7 is positive, that sign will be positive. So we have 1 and 10, and we have 2 and 5. 1 and 10 adds up to 11, but 2 and 5 does add up to 7. So the factors are x plus 2 and x plus 5. So when we write this expression that we have in factored form, we have 3 times x plus 5 over x plus 2 times x plus 5. Okay, so the common factor, you can see that x plus 5 is going to cancel, so we have 3 over x plus 2 as our final answer. So this problem wants us to think about the graph of the function f of x and find the coordinates of the whole. So remember, the whole is going to occur where we have a common factor. Okay, so what we need to do is factor the numerator and denominator and look for a place we have a common factor. So we have x squared minus 4x minus 12 in the numerator, and so we're going to think about how to factor that. So if we factor it, we have negative 12, and we need two factors of negative 12 that are going to add up to negative 4. Well, 12 is negative, so we have a positive and a negative factor. So the factors of 12 are 1 and 12, and since 4 is negative, I'm going to make the bigger factor negative. So if we factor this out, we have 1 and 12, we have 2 and 6, and we have 3 and 4. So if we add these together, 1 and negative 12 gives us negative 11, 2 and negative 6 gives us negative 4, so that's the correct combination. So in the numerator, we have f of x equals x plus 2 times x minus 6. and that is over x plus 2. So you can see here that common factor is x plus 2. So that means I'm going to have a whole where x plus 2 equals 0, and that is x equals negative 2. So this common factor, we can cancel it out, and we can do f of x equals x minus 6, and we can use that to figure out the y coordinate of the whole. So we're going to plug in f of negative 2, so that's negative 2 minus 6, and that is negative 8. So the whole is going to occur at x equals negative 2, y equals negative 8. Now let's find the equation of the vertical asymptote of the function f of x. So remember, what you want to do to find a vertical asymptote is you want to look for a place where the denominator will equal 0 and solve for x. So you can see here in the denominator we have x minus 3. So if we say x minus 3 equals 0, you can solve that by adding 3 to both sides. And so that will give you x equals 3. X equals 3 will be the equation of the vertical asymptote of this function.